is a past paper question from this particular paper here. So it's a CCEA Maths Applied A2 and it's from April 2021. We're looking at question 4 and this one is about variable acceleration, and then with that then there's a wee bit of vectors as well with i's and j's for part A. So let's take a wee look at what they want. The particle initially at rest starts to move from a point O. At time t seconds the velocity is given by 2ti plus 2t squared j. Find the acceleration of the particle whenever t is 4. So to work out A, we obviously then need to differentiate this. So that gives me dv by dt, and differentiating this, the t disappears, so we end up with 2i and then plus 4tj. We want to know then whenever t is 4, so A whenever t is 4 is going to give me 2i plus 16j. Find an expression for the displacement of the particle from 0 at time t seconds, and hence show that the particle never returns to 0. So obviously if we want to get displacement we need to take the velocity and we need to integrate that. So S is the integral of v with respect to t. So S then is going to be the integral of 2ti plus 2t squared j. Integrating that, then add 1 to the power, divide by the new power, gives me t squared I. Add 1 to the power gives me 3, divide by the new power, so it's plus 2 thirds t cubed j, and then plus c. Now we know that whenever time is 0, it starts to move from our point 0, and that's where we're asked to kind of show what it's from. So we need time is 0, that S is 0, and that means then that our C in this case then is just going to be 0. So we have that. That means our S formula is t squared I plus 2 thirds t cubed j. Show that the particle never returns to 0. So at that stage then we need to put S equal to 0. So S is 0. 0 is t squared I plus 2 thirds t cubed j. If we factorize that out, we do have another page here, so we can move to there. So I'm going to rewrite that then. That's kind of factorized, so I'm going to take out the t squared. So 0 is t squared, and then I plus 2 thirds t j equals 0. So t squared is 0, so that's the first time whenever it's 0. So that's kind of initial time. So that's the start. And then the other time is then I plus 2 thirds tj equals 0. And there's no value of t that works for that, because even if we put t equal to 0 there, there's still an I, which isn't the origin. We need both of these in to be 0. So no value of t works. Therefore, it never returns to 0. Part B then, and this is totally unrelated obviously to part A. So a model car moving in a straight line is acceleration A at time t. Car is moving with a velocity of 7 when observed at time 5. Find the total distance covered by the car in the first 6 seconds of motion. First 6 seconds of motion. So we know A is going to be 4t take away 11. We're going to have to work out V, and then we're going to have to work out S. So value for V, which is going to be the integral then of A dt. So that's the integral of 4t minus 11 with respect to t. Add 1 to the power divided by new power, so 2t squared, so v is minus 11t plus c, and we're told that whenever t is 5, v is 7, so subbing that in gives me 7. 2t squared is going to be 50, take away 55 plus c, so that means c is going to equal 12. So my formula then for v is going to be 2t squared minus 11t, and we've worked out the c to be 12 plus 12. And we have that. Now we're going to have to find the total distance covered by the car in the first 6 seconds. We're going to need to put this equal to 0 to work out the times whenever it kind of changes direction. Hopefully if you've done a few of these questions before, this is generally a dot flying along a straight line and it kind of goes back and forward. So the total distance covered, we can't just put 0 and 6 into our displacement formula. That's not going to cut it. So we need to find when v is 0. So 0 is 2t squared minus 11t plus 12. I'm not going to sit and show you how to factorize quadratics. You should know that already. 2 times the 12 gives 24, so adding kind of for that, we will have 2t minus 3, and it's t minus 4. So my two values of t, whenever it's at rest, because we've just put v equal to 0, are 1.5, and then t equals 4. So we have that to take forward. We obviously now need to work out our s formula. So s is the integral of v dt. So it's the integral of 2t squared minus 11t plus 12 dt. And s then add 1 to the power divided by new power, so it's 2/3 t cubed minus 11 over 2t squared plus 12t plus t. We're trying to work out the total distance travelled by the car in the first 6 seconds of motion. I'm really struggling to say that. So we know whenever the time is 0, we're going to just take our s to be 0 there. So whenever time is 0, our s is 0, and that means in this scenario our d is 0. So taking that forward then to the next page, our d is 0, and we have our formula then for s. That gives me s is 2/3 t cubed minus 11 over 2t squared plus 12t, and that's my formula then for displacement at any stage. Now we need to work out where this thing is at 0, at 1.5 or 3/2, and at 4. And at 6. So again, I'm not going to do all this for you, but you can check and see if you sub 0 into this, s is 0. We're going to now exchange t for 1.5. Again, just kind of plug it into your calculator, and you can take my word for it, you get 7 7/8 meters. If you sub in 4, you're going to get 2 2/3 meters. Again, you can try that yourself. Hopefully it's straightforward enough and you understand what I'm doing. Anytime I see a t here, I'm exchanging for a 4. And then finally with 6, it's going to be at 18 meters. So let's see if we can work out what's happened here. Here's my kind of timeline. They're all positive. So time is 0. We're at 0. After 1.5 seconds, we are at 7 7/8 meters. After 4 seconds, we've then come back to here, and that's 2 2/3. And then after 6 seconds, we've gone here, we've gone down to 18. So can we see what's happened? We've gone from here to here after 1.5 seconds, then we've come back to here, and then we've gone down to here. So we need to find, I guess, the total of all of these things here. So between t is 0 to t is 1.5, we have travelled 7 7/8 meters. Between t is 1.5 to t is 4, we've travelled 7 7/8, take away 2 2/3. meters. Do you see that? So going from there to there. And then between t is 4 and t is 6. We've gone from 2 2/3 all the way up then to 18. So it's 18, take away 2 and 2/3. So if we add those distances up, 7 and 7/8 plus 7 7/8 take away 2 2/3. I am terrible at using these calculators, but let's go 7 7/8 minus 2 2/3, and that equals 125 over 24, and then 18 take away 2 2/3. I think that's straightforward enough, isn't it? 18 take away 3 would be 15, so it's 15 1/3. Adding those three values up, then we get our total distance, which is going to be 28 5/12 meters.